Okay, I wanted to create a tutorial for the class based upon some of the work we did, and I'm going to choose one example of how we were creating probability and decision trees and how we were calculating conditional probability from there. In one of the examples, we talked about death penalty and murderers and their gender. So I'm going to quickly go over some of the data, and here I'm titling this decision trees, but they're also probability trees. Most people call them probability trees. So from the data, 90% of murderers are males. That means that 10% are females. 70% of male murderers murder males. So we know that obviously 30% of their victims are female. And female killers also tend to kill males. And we have 4 out of 5 who kill men. So that is going to help us create our decision tree, probability tree. What you need to do before creating the decision tree is collect all the data that you have. Okay? Put it in some type of table. In this case, we don't have all the data from the paragraph above, but we have it organized. So we have the offender, the victim, and these are both by gender, and the probability of receiving the death penalty based upon the combinations of offender and victim. I'm going to answer a couple questions based upon that. So we're going to create our decision tree. And in this case, I created the decision tree within Excel, and I took a screen capture of that and placed it in our presentation here. And in this case, what I did was I set it up by murderer, right there, the victim, male or female, did they receive the death penalty, and what was the proportion there. And then we have the last column there, which are the totals for each of the 8 branches. And all you simply do is you multiply down each branch here. In this case, we have murderer is male. One of the 2 victims they have is a male or a female. So we're going to look at male killing a male and getting the death penalty. And that probability is 0.1575. And then what you do is you, as a double check, that needs to add up to 1. Okay? When you're constructing your decision tree, probability tree, before multiplying these out, you also need to make sure that at each node the probability adds up to 1. There are 2 branches right here and here, and those branches need to add up to 1. So we have 0.7 plus 0.3, that's 0.1. We've got it. But we don't want to get confused though. But when you start multiplying out, the entire column of victims needs to add up to 1. Okay? So we're looking at males, 0.9 times 0.7. That's 0.63. And if you go to the lower branch there, 0.9 times 0.3 is 0.27. That adds up to 0.9. Okay? So in the mirror image, down below for females, we need to come up with, on that branch, that node there, 0.1. And we'll get that by multiplying 0.1 times 0.8, which gives us 0.08, and 0.1 times 0.2, which is 0.02. So these 4 right here, when you total them up, right there, 1. Okay? So now our calculations. I'm going to ask 2 questions. A randomly selected condemned inmate is a male, and a randomly selected condemned inmate killed a female. So the first question is asking about the gender of the murderer, and the second question is asking about the gender of the victim. A great way to start this off after you've created something, the probability tree, decision tree, really helps create a visual construct out of some math, which is not which is a different kind of construct, and people have difficulty with that. So what I like to do is draw basically Venn diagrams here. So in this case, we have our population set right here, set 1, this larger population. This is convicted murderers, okay? And we have this little subset within there. These folks are the condemned murderers. So after they've been convicted, there's a smaller population in this state that have been convicted and are on death row. Within there, within that subset I, there's another little subset, condemned male murderers. Okay, this isn't proportionate, but just gives you an idea. And the question we're asking, we're using conditional probability to solve. Really, what we're looking at is proportion. We're just looking at what part does subset 2 make up of subset I. So we're really just dividing subset 2 condemned males by subset I. We just have to. It sounds simple. We just need to do a couple things to get there. So in this question, we have over here, we shrunk down the tree, and there's some things over here we'll explain. So we use conditional probability, right? What is the probability that a randomly selected condemned inmate is a male? All right. So when you're looking at how conditional probability is written out, this little guy here tells us it's conditional probability, and a way to note this is given that. What is the probability that a randomly selected inmate is a male, given that we know the inmate is a condemned inmate? Okay? So this is subset I, and this is subset II right there. And how do we find that out? All right? So, which is equal to the joint probability, which is being male and condemned, to receive the death penalty. Only two ways you can get that. You kill a male, kill a female, and receive the death penalty. So we add up these two guys right there. And we divide it by the 4 ways you can get to be condemned to die. So either you're a male or female, and then you kill a male or female, get the death penalty, or female, male, death penalty, female, female, death penalty. And those are the blue arrows right there. Okay. So the joint probability ends up to 0.2655. The denominator, which is the probability of a condemned inmate, is 0.2745. This right here is a typo. It should actually say 0.001. And what we find out is that the probability that a randomly selected condemned inmate is a male is 0.967. So 97% of those folks are males. Now we're going to ask the second question about what is the probability that the randomly selected condemned inmate killed a female? Again, we use conditional probability to solve this. All right? Again, that little guy right there, conditional probability, given that. All right? And then we take the numerator, which is this joint probability, kill the female and condemned, all right? And we take this information from male killing the female and receiving the death penalty, 0.108. We add female killing the female and receiving the death penalty, and dividing that by 4 ways you can receive, 4 paths you can receive the death penalty based upon gender. Okay? Again, it's just a proportion. So we have the joint probability is 0.109. The simple probability there for subset I is 0.2745. Again, typo right there. And then 0.397 would be our answer. So that would be the probability. And using it from a percentage standpoint, we'd say 40%. Rounding it up. So hopefully that will help you all with your problem set. Thanks.